All right. Okay, so we're getting ready to slow that down because we've been going a little bit ahead because where we are right now, I wanted to take an extra amount of time to get through that. So I'll talk about the extra credit project. Let me make this a little bit bigger here. All right, the extra credit project is going to be the cumulative review of chapters in chapter 5-9, which is the end of this chapter 5. There's the chapter 5 test that we're going to study for, but then there's a cumulative of 1 through 5. Okay, if you will do those projects, and I'll send you this information, if you'll do those projects as an extra credit work, it will do two things. Number one, it'll give you some extra points, but it will also serve for studying for the midterm test, which will cover chapters 1 through 5. Okay, so this is positioned perfectly. We're on week 11. Week 15 is when this is due. You'll find over the next couple of weeks, if you'll have some extra time, if you go back through and work on those, that'll be important. Okay. All right. Now I'm going to hold off on quiz 4 and 5, and we might try to do it at the end of class, but I want to go back over and teach some other skills first. Okay. So that's the reason that I'm doing that. All right. Now. All right. Reteach imaginary units. Okay, so here's what I want you to look at, first of all, is it possible to take the square root of a negative number in the real number system? The answer is no, because a square root is a number times itself, and so you can't get a negative if you're multiplying negative times negative or positive times positive. So this becomes an imaginary number. Now, what does I represent?
Nothing.
All right, I represents the square root of negative 1. So if I'm going to interpret this, I'm going to break it down into the square root of negative 1, the square root of 4, times the square root of 3. And this would be good in your notes because in our system we have not spent the time simplifying square roots that is done in some other disciplines. All right, so not using those, you're looking for a square root of 4, a square root of 9, a square root of 25 that's hidden in this number. So 4 times 3 is 12, so if I have negative 12, I have negative 1 times 4 times 3. What is this?
I.
It's I. What is this? It's 2, and the square root of 3 can't be simplified, and so we get 2 square root of 3i. That becomes an imaginary number, but it is used as a way to talk about the solution to a quadratic equation. Now, this quadratic equation does not cross the x-axis. So we can't use the calculator to find the zeros because it doesn't cross the x-axis. Depending if this is a positive x squared, then it's going to be above the x-axis. If it's a negative x squared, it'll be opening downward, it'll be below, but it doesn't cross. All right. Now, so that leaves us with two problems. All right, and I tried to talk about them with this next line. Move this up. Okay, if these are your values for x, right? If x equals negative 2, what you're trying to do is you're trying to get a binomial that equals 0. So if x equals negative 2, and I add 2 to both sides, I end up with x plus 2 equals 0. That's the binomial that gives you this, because what happens if I replace negative 2 into this equation, or into this binomial? I get negative 2 plus 2, which is 0. Okay? Now, if x is 7/8, I have to multiply by 8 and then subtract 7. And so I get 8x minus 7 equals 0. If I replace that with 7/8, the 8's cancel, I have 7 minus 7, which is 0. Right? So those are two things that we use our algebra for. This one, the imaginary number, we can't do that. But there is a way to be able to simplify this. Okay? Imaginary binomials are in pairs, they're in conjugate pairs. One positive and one plus, one minus. Okay? So if this is the solution, can I move the real number? Answer is yes. When I do that, I get x minus 2 equals a plus or minus 3i. Okay? Now, we know that I was negative, the square root of -1, and 3 is the square root of 9, so I can transfer that back to square root of -9. So x minus 2 equals square root of -9. Now, when I square both sides, when I take this, in fact, Algebra 1 was doing this today, right? Is that when I square this, I get x squared, I get positive 4, and I get 2 times the numbers I see, because I have negative 2x plus negative 2x, which is negative 4x. So now I have this on the left side, and when I square this, I end up with negative 9. Now, I want this equal to 0. So what do I do with a negative 9? I add another 9, and I get x squared plus, or minus 4x plus 13 as the value of a trinomial that actually gave me this right here. And how do I know? Use the quadratic formula. Opposite of 4 plus or minus b squared, which is 16 minus 4 times 13. Right? I can factor a 4 out of this, and the square root of 4 becomes a 2 on the outside, so those are going to cancel. So I'm going to have 2 plus or minus, and when I have this, do you notice 4 minus 13 is negative 9? So I have 2 plus or minus the square root of negative 9, which is 2 plus or minus 3i, and that was what we started with. 2 plus or minus 3i. All right. So the calculations that you get go back to squaring this, which is x squared minus 4x plus 4. And then this side is reverted back to the square root of 9 with a negative in front. Okay, so if I had, let's try another one here. Let's say, let me move this down. We're going to talk about that one in a second. Let's say that I have x is equal to 1 plus or minus 2i. 1 plus or minus 2i. Okay, now, if I need to make this equal to 0, the first thing I have to do is move the 1. That makes this x minus 1 equals 2i. Then I'm going to square both sides. So now this is x squared plus 1, and what will the middle term be? It'll be 2 times what you see, which is negative 2x. And then when I square this side, I'm going to get negative 4. Because this actually equals the square root of negative 4. this is the square root of 1 times the square root of 4 with the square root of -4. The square root of -1 times 4. So, and then now when I bring this over, I get x squared minus 2x plus 5. The determinant, b squared 4 minus 4 times 5 is square root of -16, which is 4, but that's because it's all over 2a. All right, so that, again, I'm trying to be able to show you how you can determine what that other value is. Okay. Now, so now what we're going to talk about is page 198 of your textbook. All right, now, the reason that I'm going to go over this is that there are two things that are implied in these problems that are not necessarily clear. Okay, now, the first part, they give you a function. And then the first question A says, find f of whatever that is. Okay, now, you can do that by substitution, or you can store -3 to x, and then when you put that function into the main screen of the calculator with x already at -3, it's going to give you the value of y. All right, does that make sense? All right, so you can do two things. You can substitute normally, right, and the first number is 5x squared, so if we want f of -3, that would be 5 times 9, right? Then the next one is plus 8 times -3, which is plus -24, and then plus the constant, which is -7. All right, and that would give you the value of y, and it doesn't matter what values of x, because the function notation allows you to just do that. The other thing that you would do is that you would store -3, you push -3 in, and then go store to x, press enter, and then you'll see the -3, and then when you put in 5x squared plus 8x minus 7, it will automatically substitute for the -3 that you stored at x, and it gives you the answer. Okay, now that's the first one. The second part in number 1 on page 198 says, what is the value of x when f of x equals -3? So f of x was 5x squared plus 8x minus 7. What happens when that equals -3? Okay, now, can we do the quadratic formula? Not the way this is, but if this is 0, I can. And so what I do is I add 3 to both sides, and this becomes -4 equals 0. And now I do the quadratic formula on this equation, not the one that you originally were given. That's what B is telling you to do. Yeah. So how would you solve this? All right, it's right here. All right, so opposite of that is 8 plus or minus b squared, 64 minus 4 times 5 times -4. All right, so how much is the discriminant underneath here? Put in your calculator 64 minus 4 times 5 times -4. What is it?
144.
144. The whole thing is 144?
Oh, I didn't divide it.
No, just the discriminant.
Yeah.
All right, that's a whole number, isn't it? So I have -8 plus or minus 12 divided by 10. So what is negative 8 plus 12? 4. 4 divided by 10 is 0.4. And negative 8 minus 12 is negative 20. Negative 20 divided by 10 is negative 2. So 4 and negative 2 are the answers for the values of x if the equation equaled negative 3 instead of equaling 0. Okay. You see how that works? Now, if that was not a perfect square, then you do what you always did, and that is you would either leave it as plus or minus whatever the square root was, or you would change it to some sort of decimal form. Okay, right now let's look at problem 3. Make sure, okay, yeah. Problem number 3 is right here. If it equals 0, what I need to know is b squared 9 minus 4 times, what is it negative? Oh, because the number changed. Okay, 3 is, this was negative 9. Oh, I did that wrong. That should be a 2, shouldn't it? Okay, hang on a minute. So that may change. I hope that doesn't change my answer. This should be negative 2. So that may change it. All right, so that is 80. All right, 80. That's 79, isn't it? All right, wait, okay. So this is going to be minus, oh, how about this? 81 minus 80 is 1. Okay, I made a mistake there. All right, so that's even easier. If I'm looking at this, this is 80, right? So 9 minus 80 is negative 71, right? Negative 71. All right, now, can I divide everything by 3? All right, I can divide everything by 3, so this will end up as negative 1 over negative 2 plus or minus square root of negative 71 over 2. If I divide this by 3, this by 3, and that by 3. Now, what happens here technically, instead of having plus or minus, instead of having minus or plus. Because this negative is going to make the positive into minus, and then this negative will make the minus into plus. And some calculators actually have a minus plus sign. All right, my computer program that I use to write these actually has both of them. Okay, so, but I said that to say that the negative in here, negative 3 over negative 6 is going to produce positive 1/2. But on this side, all the negative is going to do is going to flip these plus and minuses, so it'll still be the square root of 71. Now, what is the correct form for the square root of negative 71? It is square root of 71 over 2i. You just take the negative square root of negative 1 and you separate it out, so the 71 stays there, and this is the same as the square root of negative 1. All right. Okay? Now, so what we've got in situations like this is we have a graph that we notice it's a -2, so which way does it open? It opens down, right? We could find the vertex using -b over 2a. Right, that doesn't change. So what we did first, so -b will be -3 over 2a, which would be 4. So this center is at the number 3/4, that's the vertex, right? But it's going to be below the x-axis, and it's going to come through here at 0, -10. So this point of 0, -10 is here. Now, because this was at 3/4, then I go another 3/4, and so I'll have a 1.5 comma -10 that's also on the graph here. And those two points should be lined up. All right, and that's what we did in the second section of this, is that we found, given the equation, what points can you locate? All right, we can locate the vertex. We can locate the y-intercept, and if you remember, the line of symmetry is the x value. All right, so I'm going to do a different one. So if I had that -b over 2a equaled 4, then that means that 4 comma something, f of 4, is this vertex. If the graph goes through here, and this is 0, 7. Because this is the line of symmetry, this is 4. So if I go another 4, 8, 7 is also a point on the graph. All right, that's what we did. Now, what we're going to be doing today is that we're going to be looking at using stat to be able to come up with some of these equations so that we don't have to do them by hand. Okay? All right, so section 5.8. All right, 5.8 is to review. Okay, so here's what I want you to do. We're going to take a little excursion. All right, turn to page 204. Okay, now, 204 has 3 points, and they want to know what is the equation of the line that goes through those 3 points. If it were asking for a linear equation, it would end up being a line of best fit, because those points are not the same slope from point to point, right? But what we're going to do is a quadratic equation. Okay, so the first thing we're going to do is go to stat. And I got to put my glasses on. Okay, so all right, so follow along. I will send you this. I'll send you this so that you don't have to write it. All right, now stat is up in the middle next to the. All right, now the first thing you're going to do is edit. And when you come up there, the L1 and L2, the L1 is going to be the x's, the L2 is going to be the y's. So what you're going to do is you're going to copy the x's from problem number 1, which is 1, 3, and -2. So you go 1, enter, 3, enter, and -2, enter. This is on page 204. 204, problem 1. So we're going to put the x's in under L1. Everybody see that? All right, now I hope that you don't have anything under that. If you do have something under it, if you press delete on the values underneath until that little dash line comes up, so that you only have 3 values in the column for the x's. Okay. Yeah, because we used this one time before, didn't we? Okay, now, to get the y's, use your arrow key and go over to the top And now the y's are 6, 26, and 21. So we go 6, enter, 26, enter, and 21, enter. Okay? And that's all I've got. Okay? Now, so now we have the 3 points, and we're going to let the calculator plot them. Right? So we have got to help the calculator get ready. So we're going to go to y equals. Now, if you don't want to clear out any equations that you already have there, all you do is get on the equal sign and press enter, and the highlighted equal sign on those equations will go blank. That means it's not going to graph it. All right, so if you have some equations, don't zero them out. Just get over on the equal sign and press enter, and let that highlight dark go to white. Okay? That way, if you had something that you were in the process of using, you don't have to eliminate it. It's just not going to be used. Now, go up to the top, and when you get 1 above the y equals, you're going to be on the plot number 1. Okay? Make that dark. Press enter. Now, I already had mine dark, and when I pressed enter, it turned it to white, so I have to press enter again. Now, when you bring the arrow down 1, you'll notice plot 1 is on. It's going to plot the stat that you just put in the calculator. Right now, in order to do that, we also need to make sure that our window is right. Okay, now, so we're going to need to go at least up 26. So let's go to window and let the x minimum of -10 be there, but let's make the x maximum 40. And then the change can be 1. Now, the y value, we're going to use -10, 40, and a change of 1. And when you press calculate, you should see the 3 boxes of the 3 points. All right, anybody not have the 3 boxes showing up in that window?
Yeah.
Okay. All right. What did you change the window form?
Yes.
All right. So you have -10, 40. The x change is 1, and then you have -10, 40. Y change of 1. Okay. Now when you go to graph, is it there?
Yes.
Okay. All right. Good. Now, what we want to do is we want the calculator to calculate it. We want a line to go in there. So what we're going to do is go to stat again and slide over 1 for calc. Now, we want a quadratic equation. So which one are we going to use?
Number 5.
Number 5. So all you have to do is press 5. Now, the L1 and L2 are the way we want it because we put the x's in L1 and we put the y's in L2. So we go down to where it says calculate and press enter, and you're going to get the A has to be 3, the B has to be -2, and the C has to be 5. So our equation is 3x squared minus 2x plus 5. Now, if that's all we needed, we were done. But now let's go into y equals and let's put that in. Let's see what happens. So go down to an open one, and you're going to press 3x raised to the second minus 2x plus 5. Whoa. Look what happens when you graph it. It goes right through the points. All right? All right, isn't that cool? All right, so this is stat. It's a little different than matrix as far as what the numbers, how the numbers get entered. All right, the calculation you have to go down to calculate, but that's because you can actually switch the L1 and L2 and get the inverse, but we don't want to do that right now. Okay, so what we've just proved is that this equation that we entered in the calculator, 3x squared minus 2x plus 5, is the line of best fit because it went right through those boxes that we entered in the stat. Okay? Now, why is that important? We've skipped this entire chapter because to do this by hand took a long time. And I'm not going to teach you how to do it by hand because we just did it more handily than doing it by hand. Okay? All right. So that skill sets you up for testing purposes, and also sets you up for Math 133 when you take it, because you're being asked to come up with the line of best fit given these points. So you put the points in the calculator under stat, and then you tell the calculator to, based on those points, the calculator goes through the hand method and comes up with the A, B, and C of the line of best fit. Now, 2 years ago, we did it by hand, but it's not necessary because we're moving up to one step in the calculations. All right, so I think that you should be able to do at least one of those. All right, it's not that hard, right? And so you just have to remember what the stat is. Okay. All right, isn't that cool? All right, now, let's see, go to page 211. 211. All right, 211, problem 3. Okay, problem 3 on page 211 is talking about this particular piece of information. We have age in years and accidents per 100 million kilometers driven. Okay, those are points on the graph. So, what is the first point? Based on the information, if you're 20 years old and you drive 100 million kilometers, of the people that are 20 years old, there are 440 accidents. If you're 30 years old and driving that amount, there are 280 accidents. If you're 40 years old and drive that many kilometers, there are 200 accidents. Put those into stat. So you go stat, edit, and the x values are 20, 30, 40. That's not hard. And the y values are 440, 280, and 200. Okay. Now, based on that, we need an equation. Right? And they say, assume that the relationship is quadratic. Right? So, we've got L1 and L2 retyped for the new data. All right, how do we get the equation? You go back to stat, and then go over to calc, and then do what? Quadratic. Okay, so you press 5, and then go down to calculate, and what's the equation say? So 0.4 x squared, because the a is with the x squared, then minus 36x plus 1,000 is the equation for any age person. Because the 20, the 30, and the 40 were the ages of the people. All right, so you see where the equation came from? Now, you don't have to put it in the y equals, because we just use the information to be able to write the equation. Now, if you wanted a particular thing, you could put this equation in the main calculator and then use stow to x to find what value you wanted. So you don't have to use, you don't have to take it back to put it, but why did we do it in the y equals? Because I wanted you to see that that was the line of best fit that went right through your boxes. Now we can do the same thing, only, I don't know, will the boxes show on this one? Alright, it probably
I just drafted it.
does.
All I see is like this one line coming through, so that shows you how big the arc is. It's like you can't see the boxes.
Alright, that's weird. I wonder why.
It's probably on the screen.
Well, no, we didn't change the, that's interesting. I wonder why that is, but I'm not worried about it. I'll tell you why. Just go back to y equals, get up on plot, and press it twice to recenter it. I know why, because they're off the screen. The x numbers are larger than what we have, so they're not on the screen. All right, doesn't matter. Okay, so we're moving on. We're moving on. Okay, so now what we've done in the assignments for this class is that we've skipped the word problems because you solve the word problems the same way we solve those 3 points using stat. Right? The word problems, that there is a hand method that really takes a while, but there's a hand method for doing that, but I'm not even going to teach you that because stat is what you're going to use. Okay? Now the next thing that we're doing is on page 231. All right, page 231, this is the new information that I want to spend a little bit of time talking about. Okay, so I'm going to move this out of the way just a bit. Whoa, sorry. Straighten this up. Okay, now. You look at the chapter test, and why am I on a different page here? It says page 231, chapter test, but 231 is the next chapter.
I was going to say, we're jumping to chapter 6 already?
No, I'm going to talk to you about chapter 6. All right, okay, go back to 224 is where it is. Page 224. 224, 5-9 is about 4 pages long. It is the cumulative review of chapters 1 through chapter 5. That is your extra credit problems.
So we do all of them?
Yeah, you're going to do the extra credit you're going to do the extra credit project. And it says 1 through 3, 5, 8, and 10. Okay, 5 is weird.
Oh.
Okay, 5 is weird, but you're going to have to try to figure it out. And
That's number 4.
is that 4? Oh, that 4? Okay, they've skipped it now. Good. Good. Okay. All right. So that's that part. All right. When we go back to the chapter review, the chapter test. If you look at the chapter review, all right, go to page 221. This should have been 221. That's the problem here.
Number 9.
It's 221. Okay, 221. If you look at R1, all right, that's a problem that we just talked about. What does f negative 5 mean? It means change the x to negative 5, get the answer. Okay, and R2, do the squaring. If you remember, you square the first term, you square the last term, and 2 times the numbers that you see is the middle term. Okay, so you're just doing some of the work there. All right, in R3, what's the trick? Why does it say watch out in R3? It's supposed to equal 0 in order for you to solve it. It doesn't. All right, so that's why that's tricky. And therefore, in the problems that say, what happens if the function, or can the function equal negative 4? Okay, now, well, again, it might, but if it does, when I add 4 to both sides, so I have an equation equals 0, the determinant, b squared minus 4ac, has to be 0 or a positive number. If it changes the determinant to a negative number, then there's no real answer, and therefore the value of y can't be whatever that was, in this case negative 4. All right, that becomes the question. And so if it asks you, can f of x be 22? Right, so you write the equation and you said equals 22. You subtract 22. If the determinant is 0 or a positive number, then yeah, you'll get a real answer. And so therefore, yes, x or y could be 22. But if you get the square root determinant, if it's a negative answer, discriminant, not determinant. If it's a negative answer and can't be the square root of a negative number because you have an I, then the value of the function will never be whatever that number was. Okay, so that's the skill there. All right, so now turn the page. R4. All right, we're not plotting that. So that gets skipped. When it says solve, what do you have to do in 4C?
X equals 0.
All right, you have to get it equals 0, so you're probably going to distribute the right side. You'll distribute and then combine the like terms on the other side, get it equals 0. And it may or may not be real, but that's okay because you're going to use the I if it's not. Okay, R5 is one that you can do. That's the problem that's part of the homework. Now, R6. R6 is going to be skipped according to this. How would you do R6?
Stat.
Use stat. Put them in stat, and then go stat calc and quadratic and write it down. Okay? So you're ahead of the game there. And then really the same thing with 7. With R7, you have to figure it out. Look, if you read R7, you see where it says 1 second, 2 second, 3 second? Okay, so that's the x's. The y's are 24, 18, and 2. So if you were to throw those into stat, and then do stat calc 5 for quadratic, you would have the equation that those points go through. Right? And so with this particular skill that we have using stat, those are doable. And one of the things that I'm going to argue this summer is that we need to go back and incorporate those chapters that we skipped, because it's a slam dunk. That's not hard at all, is it? Right? So it's doable. It's just another fact that you'll have. So when you see those things, now, if you look at 2 points and you need the line going through the 2 points, you can use stat. Only you don't use stat 5 because that's quadratic. You use stat calc 4 because that was linear. right? And then as we move into the exponential, you could actually do the same with the exponential function, because that's stat calc 6. Okay, all right. So that's where the testing is. And let's see, why does this not work? When it dies, it doesn't go anywhere. Okay, so you're going to do 5, 5, and then you're going to jump to 5, 8, which is the review, and then I will send you the information for the project for extra credit. And now we're going to talk about a little bit about watching these videos. All right, in 6-1. Okay, so turn over, if you will, please, to page 229. Yeah. Y equals A B to the X. Okay, the variable is still X, at least. The variable is still X, but it's in the exponential part right now. And so we're going to start with the A is going to be 1. Okay, so if I give you this, y equals a base of 2x, what happens when x is 1?
The answer is 2.
Then it's 2. All right, so 1, 2 is the point on the graph. All right, what happens when x is 2?
The answer is 4. X is squared.
It's 2 to the second power, which is 4. When x is 3, you have 2 to the third power, which is 8. And when x is 4, you have 16. Okay, now, when x is 0, you have 1, because any number to the 0 power is 1. Now, let's go backwards. What happens if I have negative 1? Negative 1 means take this number and throw it to the bottom of the fraction. So that's 1/2. The 2 goes to the bottom of the fraction, 1/2. If I'm at negative 2, I have that to the bottom of the fraction, it's 1/4. If I have an exponent of negative 3, then I take it to the bottom of the fraction, it's 1/8. And if I have negative 4, it's 1/16. All right, and what happens is I have this. If that's 1, that's when x is 0, it's 1. When I'm here at 1, I'm at 2. When I'm here at 2, I'm at 8. I'm sorry, I'm at 4. And then when I'm at 3, I'm at 8. All right? So it's going like that. But when I'm at negative 1, I'm at 1/2. So this end goes up to positive infinity. This end goes to negative infinity along the x, but I never touch the y-axis. So the whole graph is above. So y equals 0 is an asymptote. Now, if I would have had this and my base number would have been 3, then this would have shot up a little bit faster because I would have still gone through this, but at 1 I would have been at 3 instead of 2, and at 2 I would have been at 9 instead of 4, and so it would have shot up faster and it would have gotten down to where I really couldn't tell whether it was on the line as it approached the asymptote. It would have got there faster also. Right? So that is the change in base. So as long as the base is greater than 1, this is what the graph looks like. Okay, now turn the page. Page 231. See the graph? Yes.
It's 10:30.
Oh no. So I'm going to add the quiz to your homework because it's time to go. All right, thank you. Have a good day.